So recording of the session is started. All right. In our last class, we talked about some of the basic concepts related to mechanics of materials, and our main focus was on beams. We discussed that what a beam is, what are different types of supports, what are different types of beams, and what are different types of loads that beams are subjected to. And we discussed the concept of determinate and indeterminate beams and degree of indeterminacy. And further, we talked about shear force and bending moment. So anybody having any question about these basic concepts? If you have any question about our last lecture, raise your hand.
Yes, sir, I have a question.
Okay, 86, please go.
Yes, sir. लाइक जब हम एक्सटर्नल लोड अप्लाई करते हैं तो जो शेयर फोर्स प्रोड्यूस होती है सर वो सर मतलब उसकी डायरेक्शन बिल्कुल अपोजिट होती है लाइक ट्रांसवर्स लोड हमने किया तो उसकी डायरेक्शन उसके बिल्कुल अपोजिट होगी
Actually, the tendency or the shear force, what is the definition of shear force? Shear force tries to slide one section relative to the other. So at any particular section, the shear force has two directions. On one face of the section, it is downward, and on the other face of the section, it is upwards. Today, the first thing that we are going to discuss is how to calculate shear force and what will be our notation, positive notation for shear force calculation. There I will mark shear force and bending moment on the section, and then you will see that shear force at any particular section is present in both the directions. On one face it is upwards and on the other face it's downwards. That is why it has the tendency of sliding the sections against each other. So at any particular section, shear force has opposite direction on both the faces. Okay?
Yes, sir. Thank you so much.
All right. So 86, if you are done, just lower your hand. Okay, so with this now, let's start with our today's discussion. First thing that we are going to talk about is shear force. Last time we saw the basic definition of shear force, that shear force is a force that tries to slide one section relative to the other. Now, today, in addition to the definition, I want to show you that how to calculate the shear force. If I give you a beam, then how to, and I ask you to calculate shear force at a particular section, then how will you do that? First, we'll see that theoretically, and today we will be performing at least 2 or 3 numerical problems about shear force and bending moment calculations. Then you guys will become more clear about that. So the way we calculate shear force is that shear force at any section is calculated as the algebraic sum of all the transverse forces either on left side or right side of the section. Means that, for example, I give you a beam, let's say a simply supported beam, and one load is acting here supposedly, and I ask you, let's say I ask you to calculate shear force. Support this load is P. The value of shear force, it is always calculated for a particular section. The value of shear force at this section will be different than the value of shear force at this section. Within certain region of a beam or certain portion of the beam, the shear force may be constant, but as a beginner, we do not know that what will be the situation. So every time we will be calculating it for a particular section. And we will be dividing beam into certain portions. Just in a short while, we will discuss that. So shear force for any particular section is calculated as the algebraic sum of the transverse loads present either on the right side or on the left side of the section. Under the application of this load, one reaction will be generated here and one reaction will be generated here. If I ask you to calculate, let's say, shear force at this section, what will be your procedure? The procedure will be to consider a section. I'm just drawing the beam on a bit in large scale. Okay, so our convention to show the shear force will be like this. This is how we will show shear force at any particular section. Now this load, we are talking about this section. So this load is present somewhere over here. These are the two shear forces, one on the right side of the section, other is on the left side of the section. Their value or their magnitude will be equal. And these are the bending moments generated. Whenever we cut a section, on that section, we have to mark shear force and bending moment. And these, the direction of shear forces that we mark on both the sides of the section, they are opposite to each other. Similarly, the direction of bending moment that we mark on the section are opposite to each other. And according to our convention, like this is V, and this is also V. This is moment M. This is moment M. Means that both these moments are equal to each other but in opposite direction. And this V, again, both are equal in magnitude but opposite in direction. And we will consider this notation as positive notation. Means that if shear force on the left side of the section is in the downward direction and on the right side is upward, this is positive notation. Similarly, on the left side, if movement is in counterclockwise direction and on the right side movement is in clockwise direction, we will take that as positive. At this point, just note down these notations. When we will be solving the numerical problems, then these things will become hopefully crystal clear, that how we actually consider these shear forces and bending moments and what the notation is. Okay, so I just explained that how to calculate the shear force. I repeat that shear force at any section is the algebraic sum of all the transverse forces on either left or right of the section. Means that if we want to calculate shear force on this section, okay, I missed these reactions. So if I want to calculate shear force on this section, I will consider all the forces either on left side of the section or on the right side of the section. And I will take algebraic sum of them. In this case, on the left side, only one force is present. So we will just take that force and this V, which is present at the cross section. And if we come from the right side, we have this reaction and this externally applied load and this V. So we will consider these three forces to calculate the shear force. So shear force at any particular section is the algebraic sum of all the transverse forces on either right side or on left side of the section. Similarly, bending moments are calculated, or bending moment at any particular section is calculated as the algebraic sum of all the bending moments either on right side or left side of the section. And these bending moments are due to transverse loads. So bending moment at any section is calculated as the algebraic sum of moments due to transverse loads on either right side of the section or left side of the section. This is how we calculate bending moment. Okay, when we will be solving numerical problems, then you guys will become 100% clear about this, that how we actually calculate it. But before going into the numerical problems, I just wanted to give you an idea. All right. So shear force, bending moment calculation. We'll solve problems just in a short while. Okay, with this we have just a couple of more basic definitions, and then we will move to the numerical problem. One definition is elastic curve. Elastic curve. Now supposedly I have a simply supported beam and a load is acting here. So the beam will bend down like this. So this line is elastic curve. So if I want to define it in proper words, it would be the deformed shape of a structural member under the influence of external loads while the material is still within the elastic range. I repeat that, the deformed shape of a structural member under the influence of external loads while material is still within the elastic range. So when I apply load, this is center line or longitudinal axis of the member. When I apply external load, this load may be a point load or a UDL or a VDL, the beam deforms under the application of applied load. So this deformed shape is termed as elastic curve. Whenever we will be solving problems related to shear force and bending moment diagrams, we will also draw elastic curve of the beam. So in almost all the problems, we will be asked to calculate to draw shear force diagram and bending moment diagram, as well as elastic curve of the beam, or in simple words, it is the deformed shape of the beam, deformed shape of the longitudinal axis. And as the name suggests, elastic. So it is the case when the stresses and strains are within the elastic limit. And what do we mean by that? By that we mean that if we unload the member will regain its original shape. By being in elastic range, what do we mean? We mean that if we remove the external load, the member will come back to its original shape. Okay, so in this course, all our discussion will be in the elastic range. We will always be loading our specimens within the elastic range. Okay, so this was elastic curve. And another definition is of deflection. Deflection. Another definition is of deflection. Now, if we want to define deflection, we may say that movement of a point on a structural member measured from the undeformed reference axis. Movement of a point on a structural member measured from the undeformed reference axis. And in case of beams, the reference axis is the longitudinal axis. The reference axis, in case of beams, the reference axis is longitudinal axis. Now, if on this diagram I want to mark that what is the deflection. Here is the deflection. And deflection for every point is different. Like this is deflection. Similarly, this is also deflection. Okay, so the movement of any point on any structural member from the undeformed reference axis is termed as deflection. Or in this case, deflection will be defined slightly differently. Let me just remove this one. For this point, at this point, just consider that this is deflection. Actually, In this case, we'll have to draw the tangent and then we'll see the deflection. I don't want to go into that detail, but at this case, just consider this is the deflection. But at any point of the beam, the deflection is different. And whenever we will be calculating deflection, we will be calculating it for a particular point. After the shear force diagram and bending moment diagram, deflection is our next main topic that we will be covering together. Okay, so these were some of the other basic definitions that we could not cover in last class. So I just covered them. Anybody having any question about these basic definitions? If you have any question, please raise your hand. Okay, 84, please go ahead.
Sir, can you please repeat the definition of elastic curve?
Okay. You are 86. I asked 84 to go ahead, but anyways, elastic curve. Now, what is elastic curve? Okay, let me answer. Let me answer first now. So elastic curve is the deformed shape of a structural member. See, this was the original shape. Let me come back to my camera. So this is the original shape or center line of the beam or longitudinal axis of the beam. Under the application of external load, the beam sags down like this. So this is the deformed shape of the beam. And this deformed shape of the beam, if the beam is within the elastic limit, then it is termed as elastic curve. Okay, the deformed shape of a structural member under the influence of external loads, while the material is still within the elastic range, is termed as elastic curve. Is that clear now?
Yes, sir. Thank you, sir.
Okay. So who else raised his hand? 86, if you are done, just lower your hand.
सर वो 84 ने पूछा था.
Oh, वो 84 था. Okay, 86, then go ahead.
यस सर, ये जो शेयर फोर्स में आपने लेफ्ट साइड का बताया हुआ है कि शेयर फोर्स अलजेब्रिक सम है सारी फोर्सेस का. सर मतलब हम लोगों ने जब उसे कट किया तो हमने एक साइड पे लिया पॉइंट लोड जो हम लोगों ने अप्लाई किया था, हमने दूसरी साइड पे क्यों नहीं लिया?
I mean, I have considered this section, like in this diagram, I have shown the detail for this section. Right? And this was the applied loading. It depends upon the given problem. There may be 1, 2, 10 or 1,000 different applied loads. So it depends upon the applied load. In this case, the load was acting only at this point, and I wanted to consider shear force. I wanted to consider shear force at this section. So I have cut the details of this section here. Is there any external load applied on the left side of this section?
No, sir.
No, that's why I did not mark a force here. But is there a force applied on the right side of the section?
Yes, sir.
Yes, so I marked it here. So it all depends upon the external loads. When we will be considering a section, we will have to keep the external loads at their places. Okay.
सर हमें कैसे पता चलेगा कि हमने यहाँ से इसको कट करना?
It will be like the problems that we will be discussing together. We will be drawing shear force diagram for the entire beam, and in this in that case we will be taking section throughout the length of the member. I will just explain in a short while that how to decide that how many sections should be considered. So if you are asked to draw a shear force diagram and bending moment diagram for the entire beam, you will have to cut several sections. And we will learn that how to decide that. But in some of the cases, you might be asked to calculate shear force at a particular point. In that case, you will just consider one section passing through that point. But we are going to discuss that just in a short while. Don't worry about that. Okay?
Yes, sir. Thank you so much.
All right. Any other question?
सर ये जरा पॉजिटिव नोटेशन का बता दें शेयर फोर्स का.
Sorry, what? क्या बता दें?
सर ये पॉजिटिव नोटेशन.
Positive notation. If we consider shear force downward on the left side and rightward up, on the right side we consider it's upward, we call this a positive notation. Okay. And if we consider movement on the left side of the section in counterclockwise direction, and on the right side we consider it in clockwise direction, we consider that we call this overall notation as positive notation. When we will actually be considering section, at that in that case we can assume these directions to be clockwise, counterclockwise, upward, downward, that is flexible. Actually the answer of our the sign of our answer will tell us that whether the assumed direction was correct or not. At this point, just note this down. When we will be solving the numerical problems, I will explain about this, about the implications of considering shear force and bending moment in certain directions. And these things are just conventions. What is a convention? Convention is a practice, and it's not a rule. It's not something hard and fast. It's not like fixed, rigidly fixed. We can change the conventions, okay? But I always suggest my students to initially decide a convention and then stick to it. You can, like, it's possible to change your convention in every numerical problem, right? But what happens is that if you do that, then you yourself get confused about these conventions at certain point. Oh, should I take clockwise positive or counterclockwise positive? My answer is coming out to be negative. Now, what does it mean? And in certain cases, answer is positive. What does that mean? So if you keep on mixing the conventions, it creates a lot of confusion. So in a short while, before jumping to the numerical problems, I will explain that what convention we will be using, and we will stick to that. Although it's possible to keep on changing it, but that's not recommended. Okay, so just give me a few minutes and then I will explain the convention that we will be following. And when we will follow that in the numerical problem, it will become even more clear. Okay.
Okay, sir.
All right. So with these basic definitions, now let's see the steps in beam solution. We will be solving beams throughout this semester. Steps in beam solution. Okay, step number 1, calculate reactions. So whenever we are provided with a problem and given with a diagram, what we'll do, our first step will be to calculate reactions against the applied loading. In our last class, we discussed in detail that what are different support types and what are different reactions that can be generated on those supports. So we already know that. So whenever any beam is given to us, we will identify that which reactions can be generated, and then we will quickly calculate those reactions. This will be our first step. Second step, divide the beam into portions. Now somebody asked that how do we know how many sections to be considered? So what we'll do, we will divide a beam into number of portions, and how these portions are divided, whenever there is any change in applied loading or support condition, we consider that portion as one segment, or we consider that part as one portion. So whenever we define portions or in a way that whenever there is a change in applied loading and applied loading or support condition, we jump to the next portion. We say that, okay, for example, if we have let's say simply supported beam like this, and I have a point load here. So what I'll do, I have one reaction here, I have one reaction here. When I will be solving this beam, I will divide this beam into two sections. Why? Let's start from this point. The situation is constant. There is no external load. Like I have a reaction at the beginning, and then I'm moving in this direction. There is no external load up to this point. Okay, so and no change in the boundary condition or support condition. So from this point to this point, let's say this point is A, this point is B, and this point is C. From point A to B, there is no change in the applied loading. So I consider AB as one section. And then starting from B up to point C, there is no further change at in the loading or boundary conditions. By boundary conditions, I mean support conditions. So there is no change. That is why we can consider portion BC as another segment or as portion. So while solving this beam, we will consider two sections or two portions, AB and BC. And in every portion, we will consider one section. Okay, so this is our second step to divide beam into number of portions. And when we will be solving different problems, we will see how many different sections we need or portions we need. Okay, and then in every portion we will consider a section. For AB we will consider one section. For BC we will consider one section. Step number 3. Write equations of force and bending moment. We abbreviate shear force as SF and bending moment as BM. So write equations of shear force and bending moment for each portion. Okay, when we defined shear force and bending moment at the beginning of today's class, we said that how do we write down the equation or how do we calculate shear force? It is the algebraic sum of transverse loads, all the transverse loads either on the right side or on the left side of the beam, of the section. Similarly, bending moment is the algebraic sum of all the bending moment at a particular section is the algebraic sum of all the bending moments either on the right side or on the left side of the section. So that's how we will be writing down the equations. When we will be solving numerical problem, I will we will see that in detail. Okay, so this was our third step. Next, get shear force for each portion. Once we have the equation for shear force and bending moment, we will, using that equation, we will calculate shear force for each portion. What we'll do, we will calculate the shear force at the starting point of the portion and at the ending point of the portion. For example, for portion AB, we will calculate the shear force at point A and shear force at point B. These force values will help us in finally drawing the diagram, shear force diagram and bending moment diagram. Next step is draw SFD. What is SFD? By SFD, I mean shear force diagram. SFD is shear force diagram. Shear force diagram is a diagram that tells us about the variation of shear force throughout the length of the member. When we will draw shear force for this member, a shear force diagram, that diagram will tell us how shear force is changing throughout the length of the member. When we will have that diagram, I hope you will get good clarity about this. Okay, after this, get bending moment for each portion. Once we have got the shear force and plotted the shear force diagram, next thing is to get bending moment for each portion. We have already written the equations. We'll get it for each portion and then we will draw BMD. By BMD, I mean bending moment diagram. Bending moment diagram. And SFD is shear force diagram. we will be drawing a lot of shear force diagrams and bending moment diagrams in this course, and even in maybe like a lot of courses that you will study in future, you will be drawing shear force diagrams and bending moment diagrams. So this knowledge is something that's going to go along with you guys for a long time. Okay, last step is draw elastic curve. Draw elastic curve. Elastic curve is abbreviated as EC. So the last point in beam solution will be draw elastic curve. Okay, so these are the steps that we will be following while solving any beam problem in our case, while drawing shear force diagram and bending moment diagram. Now let me highlight or clearly state the convention that we will be following. Okay, when we defined shear force and bending moment, I said that the shear force as well as bending moment can be calculated from either side of the section. The shear force can be calculated from the left side of the section or from the right side of the section. Okay. As a beginner, we will fix one direction and we will always be moving from left to right. Okay. Although it is possible to write down the equation of shear force and bending moment from both left side and from right side. But as a beginner, we will be fixing one direction. We will always be writing down the shear force diagrams and bending moment diagram equations from the left side. At some later stages, when we will get a good hang of all these things, we will solve some problems from the other side of the beam as well. Because in some of the cases, it is convenient to approach the problem from the other side. We will discuss that at a later stage, not right now. So our notation that we will be following will be notation. We will always be moving from left to right direction. We will always move from left to right, and in this direction, our shear force V upward will be positive and shear force downward will be negative. This is the convention that we will be following. We will always move from left to right direction in solving the beams, and we will take upward shear as positive and downward shear as negative. And for bending moment, again, we will be moving from left to right, and our convention will be we will take clockwise movement as positive and we will take counterclockwise movement as negative. Note down this convention and keep it in your mind. We will be using this convention all the time. We will always move from left to right, and we will take upward shear as positive, downward shear as negative. And again, for bending moment, we will be moving in the same direction, and we will take clockwise movement as positive and counterclockwise movement as negative. And I repeat that this is our convention. I'm not saying it's a rule, and it is like in every book or in every article that you will read on internet or in some hand written notes, this convention will be same. I'm not saying that. We are fixing this convention for our convenience, and most of the time this convention is followed, but not always. Okay, for us, as we are beginners, so we will just stick to one convention, and that is this convention. Okay, is that clear? Anybody having any question about this beam solution steps and our convention. Okay, I don't see any hand raised. So let's move on. Keep this convention in your mind. This is extremely important. So with this, I think we are ready to solve our first numerical problem. Now we have all the necessary information for the solution of beams. So let's start with our first example. Example number 1. And this is probably the simplest case that you will ever encounter. We have a simply supported beam and a point load P is acting on the beam and its magnitude is equal to 10 kilonewton. And total span of the beam is 10 meters and this force is acting at 5 meters from support A. This is support A, point of application of load is B and C. So it means that the load is acting at mid span. 10 meters is the span length, load is 10 kilonewton and it is acting at 5 meters from the left support as well as from the right support. This point is A, this point is B, and this point is C. Now, if we look at the steps of our beam solution, what is the first step? Anyone? Just read first step.
Sir, calculate the reactions.
Calculate the reaction. That is our first step. Okay. So let's calculate the reactions. How many reactions do we expect in this case?
2. Sir, 2
Three.
reactions.
Sir,
Three reactions.
3 reactions, sir.
Three
Sir, 2.
reactions. Okay. Okay. Roll number 73. Roll number 73.
Yes, sir.
Okay. So somebody said that we expect 3 reactions. Do you agree with this?
Uh, Sir, I think there are 2 reactions.
Okay. Why 2?
Sir, A and C.
AX?
Yes, sir.
Sorry, I could not understand. Just repeat.
Sir, I think there are 2 reactions.
There are 2 reactions. Which 2? What will be
Sir,
the origin?
Sir, at A, point A and point
At
B.
A? At A, what reaction? Like horizontal or vertical?
Sir, vertical.
Okay. What about horizontal reaction at A?
Uh,
What type of support is this? Can you name this support? What type of support is this? 73, do you remember?
no, sir.
You don't? Okay.
Sir, I didn't take the first lecture. That's why I cannot.
You skipped first lecture?
Yes, sir.
Oh, that's not good. All of you must be very regular in this class because we will be building up on the foundation that we will make in these initial lectures. Now, see, you skipped last class, so you do not know what type of support is this.
Yes.
Okay. So that's going to be a problem. This is hinge support, and it can generate 2 reactions. Okay, Umar Abdi, you want to say something? Your mic is on.
Maybe it's for reaction.
It will have
the-
4 reactions.
Yes.
Okay, and what will be their location and orientation?
Yeah. The first beam is a hang beam, hang support beam.
In support, okay.
The two reaction. One
Two
is a
reactions.
vertical,
One is vertical,
one is a horizontal.
one is horizontal.
And
What
another
else?
another beam is a roll support beam.
Support at B.
No. C.
C, okay. How many
S-
reactions at C?
one reaction,
One
one
reaction.
force. Yeah.
So
The
is that
four
it?
the four one is the applied load.
The fourth is
The fourth reaction is applied load is at 10 Newton.
10. Actually, this 10 kilonewton is not a reaction. It is an external load. It's an applied load. You can say this is action, and these three are reactions.
Okay.
Okay. So P is an external load, and reactions are also kind of external loads, but these are not like you cannot say that there are four reactions. You can say that there are four forces. One is externally applied load, and three are reactions generated against that. Now, okay. So in this case, we have a simply supported beam. Hinge support has the capability of generating two reactions, one in vertical direction and other is in the horizontal direction. Let's say we call the vertical reaction as RA and the vertical reaction here as RC. What about the horizontal reaction? Although support A is a hinge support and it does have the capability of generating horizontal reaction, but in this case, as there is no horizontal force applied on the beam, so there will be no horizontal reaction generated at support A. Hinge support does have the capability of generating a horizontal reaction, but the reaction will only be generated if there is some action. So there is no horizontal force acting on the member, or in other words, in the horizontal direction, there is no action. So no reaction will be generated in the horizontal direction. So in this case, only two reactions will be generated, a vertical reaction at support A and a vertical reaction at support C. So two reactions are there. Now, in this case, which equations of equilibrium we need to apply in order to calculate these? We will apply sigma Fy equal to 0 and sigma m at any of the points equal to 0. We will see that. And whenever you apply these conditions of equilibrium, it is preferable to write down the sign convention with that. So our convention for this will be upwards positive for clarity. Okay, we are going to apply sigma Fy equal to 0 and we will take upward direction as positive. So how many total upward forces are there? Let's say we start from this direction. RA, it's acting in upward direction, so it's positive. What next force we have? Next force is this 10 kilonewton force acting in the downward direction. So minus 10, and then what else? Plus RC equal to 0. So these are the three forces acting in vertical directions. RA minus 10 plus RC equal to 0. And if I rearrange this equation, we get RA plus RC equal to 10. And we can label this equation as equation number 1. We have one equation in two unknowns, so we cannot directly solve it. We'll have to generate one more equation. And for that, we can take, let's say, sigma MC equal to 0. You can take sum of moment at either of the supports equal to 0, because we know that these are hinge and roller supports and none of them can generate any resisting moment. So sigma MC, or we could have taken sigma MA equal to 0 as well, that does not matter. And what is our sign convention? We will take clockwise as positive while calculating the moment. This was the summation of forces. Now this is summation of moments. And when we calculate movement, we need two things. We need force and lever arm. Okay, we are calculating sum of movement about this point. So let's start from point A. So for RA, what will be the direction of movement of RA about point C? It will rotate the member, or it will generate movement about point C in clockwise direction. Can you guys visualize this thing? If I have this member here and it has a hinge or roller support here, I apply a force in the upward direction, so this will rotate it like this. I have a roller support here and a load is acting in the upward direction, so the load will rotate it like this. Okay, so this movement RA will be positive because it is generating clockwise movement. And what will be the magnitude of lever arm? RA lever arm is the distance between the point of application, is the perpendicular distance between point of application of load and the point about which we are calculating moment. So the distance, perpendicular distance between RA and point C is 10 meters. And as it is clockwise, so we have taken it as positive. Next force, if we move in this direction, next force that we see is this 10 kilonewton force. 10 kilonewton force is acting in downward direction and it will create a clockwise movement about point C. Okay, so clockwise is negative, counterclockwise. So this 10 kilonewton force will produce counterclockwise movement about point C. And how much is the lever arm of this 10? 10 into 5, because this force is acting at the center. What else? If we move in this direction, the next force that we see is RC. We are taking sum of movement about point C. So RC is passing through point C. And from the knowledge of our basic mechanics, we know that if any force is passing through a point, it cannot generate movement about that point because the lever arm is equal to 0. So we reach the end of the equation. RA into 10 minus 10 into. Now, please calculate the value of RA. When we will be solving these numerical problems, I want all of you guys to have calculator with you. We will be writing down the equations and we will be calculating the variables. I want all of you guys to have calculator and calculate these values, and I expect that all of you are noting this down. Okay, don't just depend upon the video lectures that okay, these lectures will be available to us, so we can just watch these lectures at any time. That option is certainly there, but I strongly recommend you that all of you write down these lecture notes, solve these numerical problems with me, calculate all these variables. Only then you will be able to develop good understanding. Okay, so I want the answer of RA from this equation. Anyone?
5.
Give me the value
5.
of RA. 5 kilonewton. Okay, so RA is 5 kilonewton. And if now we know RA is 5 kilonewton from equation 1, like we can put this value of RA in equation 1 and we will get the value of RC. How much is that?
Sir, 5.
5 kilonewton. Okay, that's good. So we have got the value of RA and RC, and it is very easy to verify that in this case our answer is correct, because you see we have a 10 kilonewton force acting at the center of the beam and we have a symmetrical situation. One support here, load is acting at the center, total span is 10 meter, load is acting at 5 meters, so it's at the center. So simply this force will be divided into two parts. 5 kilonewton reaction will be generated here and another 5 kilonewton reaction will be generated here. And another important thing to note here is that both our answers are positive, which means that the initially assumed directions are correct. Okay, our answers for RA and RB, both the answer RC, both the answers are positive, and this means that our assumed directions for RA and RC are correct. Had we get negative answers, that would have meant that the assumed directions of RA and RC are incorrect. Like if for RA answer is negative, it means the real direction of RA is downwards. If RC answer comes out to be negative, it means the real direction of RC is opposite to the assumed direction. So it would have been in the downward direction. Okay, is that clear? Anybody having any question at this point? Okay, roll number 87, please go ahead.
सर समेशन एफ वाई इज इक्वल्स टू 0 उसमें -10 जो सा है सर उसको बता दें वो कहाँ से आया
-10 कहाँ से आया?
जी सर वो एक्सप्लेन करें थोड़ा सा।
-10 is the externally applied. When we will be calculating reactions, we will consider all the forces acting on the system. I hope in your basic mechanics you have studied the topic of equilibrium.
ओके सर
All right. So how many forces are there? RA, RC, and 10. Our convention is upward positive. RA is upward, so it is positive. RC is upward, so it is positive. 10 kilonewton is downward, so this is negative. All right. Okay. Rizwan, please go ahead.
सर अगर हम काउंटर क्लॉकवाइज लेंगे तो हमारे आंसर्स भी तो चेंज आएंगे सर।
Sorry, what?
सर अगर हम assumptions काउंटर क्लॉकवाइज पॉजिटिव लेते हैं तो सर हमारे आंसर्स -5 और 15 आई थिंक सो आएंगे, तो वो तो गलत हो जाएंगे।
That's why I said that just stick to one convention. At this point, as we are beginners, so I would suggest you just stick to one convention. We have defined one convention, and for some time, just forget about other options. Because we are at the very beginner stage. If at this stage I start considering both the conventions, it will lead to confusion. So I don't want that. However, we can consider both the conventions and finally we may get the right answer. How to do that, I don't want to get into that detail at this point. Just stick to this convention. Take upward force positive and take clockwise movement as positive. That's it. Forget about other convention. I don't want to.
पेपर में हर जगह पे हम इसी तरह करें, जो आंसर्स आए वो बस हमारे लिए एक्यूरेट है।
नहीं, आंसर एक्यूरेट नहीं है। आई एम सेइंग दैट वी सेड दैट upward is positive, answer came out to be positive. Okay,
yes, sir.
It means our assumption about RA was that RA is in the upward direction. It means our assumption is correct. And similarly for RC, the answer is positive. It means our assumption about RC is also correct. Okay, that's what these positive answers mean. Right now, just forget about the other convention. Just use this convention, and at the beginning we can assume the direction of reaction in the upward direction. If answer comes out to be positive, the assumed direction is correct. If answer come out to be negative, the assumed direction is incorrect. That's all. Okay.
सर उस केस में अगर हमारी के assumed direction मतलब गलत है तो हम दूसरी वाली लेंगे।
Assumed direction, if it comes out to be negative, then while drawing shear force diagram and bending moment diagram, we will incorporate that thing. Supposedly, my answer for RA had come -5. Then in future, for my rest of the problem, what I'll do, I'll mark RA in the downward direction and then I'll solve the rest of the problem. Okay. In the problems that we will be dealing with in future, we will come across such situations when the assumed directions will be incorrect. Or actually, I can hypothetically create some situation. We can try to do that in the next problem. Okay.
Okay.
We'll see that. Bakir, please go ahead.
सर पॉइंट लोड की डायरेक्शन तो बता दें।
Point load की direction. I mean,
yes,
this
sir.
arrow is showing the direction of point load. Like what else? What else do you want to know?
Bending moment में sir.
Bending moment. I have a point load here and the lever arm is here. Oh, the pivot is here. So if I have a beam and it has a roller support here and I apply load in the downward direction, like in this direction. So in which direction it will rotate the beam? Beam is here, pivot is here, and the force is here. So what do you think? Which direction my pen is moving? Clockwise or counterclockwise? Huh?
Anti-clockwise.
Anti-clockwise. What is our convention? Clockwise movement is positive, and this load is creating counterclockwise movement. That is why I consider the movement of this load as negative. Is that clear now?
Okay. Yes, sir.
Okay. So Bakir, if it's fine, then lower your hand. Rizwan, please go ahead.
सर वो मैंने कहना था 1 hour के बाद आपने कहा था कि ब्रेक देंगे 5-10 मिनट.
Okay, let's just conclude this reaction discussion and then we'll have a break. Okay. 91, please go ahead.
सर हम यहाँ पे मोमेंट में लिख सकते हैं क्लॉकवाइज मोमेंट इज इक्वल टू काउंटर क्लॉकवाइज मोमेंट. क्वेश्चन बना सकते हैं ये वाली.
Clockwise and counterclockwise movements are equal. That is why we are saying sigma mc is equal to 0. So we are taking, like, if the same equation, what I have done, I have written all the terms on the left hand side of the equation, and I have taken clockwise movement as positive, counterclockwise movement as negative. If you want to write down the equation in this way, that okay, I'll write down clockwise movement on one side of the equation, I'll write down counterclockwise movement on the other side of the equation, then we'll get exactly the same thing. For example, this equation, we can also write it down that okay, RA into 10. Now in this problem, RA into 10 is clockwise movement, and there is no other clockwise movement, so left hand side of the equation is complete. And now I will write down equation, all the counterclockwise movement on the right side. 10 into 5 is the counterclockwise movement. So finally you see that I get a rearranged form of the same equation. So either you say sum of all the movements is equal to 0, or you say the clockwise movements are equal to counterclockwise movements. Both are just two different ways of saying the same thing. Okay, is that clear?
Yes.
Okay, Bakir, do you have any other question? Bakir, I see your hand raised. If you want to say something, go ahead. No? Okay, 71. Please go ahead.
फिर ये जो इक्वेशन है, इसमें तो फिर कन्वेंशन भी अडॉप्ट करने की जरूरत नहीं पड़ेगी. ये जो आपने नीचे लिखी है, RA मल्टीप्लाई बाय 10.
हाँ, आप you can say that. You can say that, but normally we do not do it this way. But that is correct. If you are writing down clockwise and counterclockwise movements on separate sides of the equation, then you don't need to mention the convention. That is true. But almost in all the cases, we will be following this pattern. Okay, because why? Because we start from one end of the equation, one end of the member, and then we keep on moving up till we reach the pivot point. And we write down every movement, whether it's clockwise or counterclockwise. So we want to maintain the flow of the equation. And that's the convention we will be following. But if somebody decides to write down the equation this way, then that's correct. You don't need to mention clockwise positive or counterclockwise positive. Okay?
सर एक और क्वेश्चन है कि फर्ज करें ये जो बीम है, इस पे 3 सपोर्ट्स होती हैं, एक हिंज, एक रोलर और एक और रोलर. तो फिर ये जो नीचे वाली इक्वेशन है RA मल्टीप्लाई बाय 10 इज इक्वल टू 10 मल्टीप्लाई बाय 5, तो फिर इसको किस तरह लिखते हैं, ये जो इक्वेशन आपने लिखी है नीचे?
अगर एक had there been another roller support, let's say over here at this point, we would have considered the reaction of roller support at that location, and plus that will make the beam as an indeterminate beam. So we will not be able to solve that beam using this method only. We will need some more sophisticated method to solve that beam, because that beam would be a continuous beam, and continuous beam it will be continuous and it will have degree of indeterminacy 1. Do you remember the way we defined determinate and indeterminate beams in last class? Determinate beams can be solved with through the equations of equilibrium only. But indeterminate beams cannot be solved using this method. For indeterminate beams, we need some sophisticated methods that you will start learning from next semester. Okay, so in this semester we will always be talking about determinate beams. Is it clear?
Okay, sir.
All right, so I don't see any other hand raised. So with this, at this point, we can have a break for 10 minutes and we can start at 9:15. 9:15 we will start. All right.
Sir,
Okay, yes. 84.
सर हमने इसकी डायग्राम्स क्यों नहीं बनाई shear force diagram, bending moment diagram?
We have just done the first step of the problem. We have
Okay, sir.
just completed first step of the problem. We will do that. Don't worry. Okay.
Okay, sir.
Let's stop here and we'll meet at 10:15 again. But I want to remind you that I'm here in the meeting and the recording of the meeting is still going on. So be very careful about your conversations or anything because everything will be recorded and it will be posted online. Okay. So let's
Yes,
just
sir.
stop. Okay guys, this is 9:15 a.m. So let's start our discussion again. I see several messages in the chat box regarding the attendance issue. So I will take your attendance one more time, but I want to remind you guys that I will be keeping a track of it, that which students join the class on time and which are late. And if I see some habituals, then I might not mark their attendance in future. Okay. All right. So can you guys hear me and see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
All right, that's great. So let's continue with the problem. We have just completed first step of solution of beam. We have considered a simply supported beam subjected to single load, and we have calculated its reaction. Now, what was our next step? Our next step was to divide the beam into number of segments, number of portions, right? The second step of our solution is divide the beam into number of portions. Now, how we will do that? For that purpose, we need to identify that where is the change in applied loading or support conditions. So wherever we see a change, we define a new portion. So let's start from point A. As we move in this direction, what is the location where we see first change? It's at point B. So it means that from point A to point B, we have constant loading and end conditions. So we will define one portion as portion AB, because at point B we have another applied load, so we have a change. So we need to define another portion after point B, and that portion will end where we see the next change. So from point B, at what location we see the next change? It is at point C. We have a support and a reaction. So there will be second portion BC. So this is our second step, that we define. We have identified two portions in our beam because there is variation in the loading at one point. So that point divides the beam into two portions. So one portion is AB and the other portion is BC. Now for both of these portions, we will write down equations of shear force and bending moment. So let me write down. Sorry. Let's solve both these portions one by one. Okay, so we have identified that this beam has two portions, AB and BC, and now we will consider both these portions one by one, and we will write down equations of shear force and bending moment. Shear force and bending moment. Okay, portion AB. First one is portion AB. Now portion AB, in order to solve this portion, we will be considering this section, and the section within any portion is always defined with a variable x. This is a portion, so I'll say that the location of this portion is x. Similarly, this is another portion. The location of this portion will also be x. Now, why we are defining these sections in terms of x? Because we want an equation for the entire portion. So that equation will represent the variation in shear force and bending moment for the entire portion. That is why this x will vary within the portion. For example, for portion AB, in front of the portion, we will write down that x is from 0 to 5 meters. This is the range of x, from 0 to 5 meters. Now, one clarity here is whatever load will be acting at the extreme end of any portion, that load will not be considered in that portion, because our portion actually ends right before, like there is a very small distance between the end of our portion and the point where the load is acting. So when I say portion AB, in that portion, the load acting at point B will not be considered. This load which is acting at point B, it will be considered when we will be talking about point C. So what did we say about our convention? We said that we will always be moving from left to right, and you have seen that I have marked this section from left to right. Similarly, the other section from left to right. This point is showing point A, and 5 meters is point B. But I repeat that any load that is acting at point B will not be considered in this section. It will be considered in the next section. Okay, now whenever we consider any section, we need to draw free body diagram of that section. What is free body diagram? We just draw the center line of the member as we already have here, and then we mark the relevant forces on that, and that's it. Let's see how we can do that. So for portion AB, the free body diagram will be something like this. We have hinge support at point A, and this is our section. And as I said earlier, whenever we cut a section, we have internal forces at that section, the shear force and bending moment. You remember I marked a notation at the beginning of the lecture, the positive notation. We will be considering the same positive notation here. We will consider V in the downward direction, and we will consider M in the counterclockwise direction. This is M and this is V, and this is 5 kilonewton. Oh, sorry, 5 kilonewton, and location of the section is X. This is X. So now whenever we cut a section, we will have to mark these shear force and moments. Okay, and we can mark these in any direction we want. We can mark this V in upward direction, and we can mark upper M in clockwise or counterclockwise direction. But I want you guys to stick to one convention. So I suggest that every time we mark shear force and bending moment in this direction when we are moving from the left side. Okay, I see something on my Teams. Is there any question? No, okay, no hand is raised. All right, so this is the free body diagram for section AB. For segment AB or portion AB, we have considered section at location X. Now we need to write down the equation for shear force and bending moment. Okay, for shear force, calculating the shear force, what was shear force? We said that shear force is the algebraic sum of all the transverse loads or forces acting on either side of the section. This time we are considering left side of the section because this is the free body diagram of the left side. Right side we are not considering. Whether we move from left side or right side, we finally get the same answer. We will solve some problems at some later stage. Okay, so now let's apply the conditions of equilibrium. Sigma Fy equal to 0, and our convention for this case will be upward positive. Okay, So what this equation will give me, 5 kilonewton force is acting in upward direction, so 5 positive. What else? Do we have any other transverse force? V is the other transverse force. It is acting in the downward direction, so minus V equal to 0. We have only two forces. If I solve this equation, I get V is equal to 5 kilonewton. So this is the shear for the portion AB, and as the shear is like the final answer that we have got is a constant value, it means that the shear force will remain constant for section AB. So whether we are at point A here or at point B, which is present somewhere over here. If I show this diagram, point A is here, point B is here. At both the points, the shear force value will be 5 kilonewton. How can I say that? Because in the final expression for shear force, I am not getting any x. There is no x involved. Shear force is constant. In some of the cases, it will not be constant. We will see that later on. But the shear force is 5 kilonewton here. Okay. Now we will take the summation of moment about the section. Okay. Sigma m x equal to 0. So at x distance means at the location of section, we are taking the summation of moment. And what is our convention? Our convention is that we will take clockwise as positive. Okay. And let's take moment about section. Okay, how many moments are there about this section? This 5 kilonewton force will produce a moment in clockwise direction. All right. So 5, and how much is the lever arm for this 5 kilonewton force? How much is the distance between this 5 kilonewton force and the section? It is x. So the moment will be 5x. Yes, it's in clockwise direction, so we are taking it as positive. But will it produce any movement about the section, this force V? Okay, Hasham, please go ahead.
सर एक पता नहीं नेटवर्क इशू मेरी तरफ से आ रहा है, आपकी तरफ से एक स्क्रीन काफी सर इशू कर रही है, और सर मूवमेंट का दोबारा बता
सर
दें।
आवाज भी डिस्टॉर्ट हो रही है
सर काफी डिस्टॉर्ट हो रही है सर, मैं नेट भी चेंज किया।
Okay, at my end it seems okay. I don't see any warning, but anyways I can repeat that. So you are concerned about movement. आवाज very clear नहीं है?
सर आपकी आवाज क्लियर है, मगर आपकी स्क्रीन से बहुत डिस्टॉर्शन के साथ शेयर हो रही है।
यस सर, स्क्रीन डिस्टॉर्शन के साथ शेयर हो रही है।
Okay, just
सर आवाज से ज्यादा स्क्रीन का इशू है, स्क्रीन का इशू।
Okay, now I'm using hand free. Let's see if it gets better. Okay, Hasham, do you want to say something? Hasham?
सर वीडियो डिस्टॉर्शन हो रही है काफी।
Video distortion. Okay, at my end, the signals are full and I don't see any warning on the screen. So it seems that at my end it's fine. Hopefully, it will get better. Okay, I hope it gets fixed at your end as well. So let's just continue, and this recording will be available to you at a later stage if you feel any difficulty. I can repeat the movement part.
Sir?
Okay, sir.
Sir?
Yes?
सर असल में जब आप पेज ऊपर या नीचे ले जा रहे होते हैं ना, तो वो स्टिल हो जाता है बीच में और आप पढ़ाना शुरू कर देते हैं। तो ऐसा किया करें कि पेज एक जब नीचे ले आते हैं एक बार स्टिल हो जाए तो फिर पढ़ाना शुरू किया करें, उससे बेहतर हो जाएगा।
Okay, I can do that. That's fine. Thanks for letting me know. All right. So we have this movement. Now, how many forces are there starting from this end? 5 kilonewton is the magnitude of force. and x is the distance between the force and the section. So the force is producing movement in clockwise direction. Okay, that is why I have considered this positive, because our convention is clockwise movement as positive. The other force involved is this force V. This force is passing through the section. It's exactly at the same location, so it will not produce any movement. Do we have any other movement here? This movement M is there. What is our assumed direction of movement?
Minus.
Okay, the assumed direction of movement is in counterclockwise direction, so it will be minus M. And there is no other movement involved, force or movement involved in this system. So if I rearrange this, I get M is equal to 5x. Now what does this mean? This means that the movement is varying along the length of the segment, because x is a variable, and in the expression of M we have x. Unlike the expression for V is constant, but M is not constant. M is equal to 5x. So what we will have to do, we will have to now calculate this movement for point A and point B separately. At point A, what is the value of x? X is 0 at point A, because x is starting here. So this implies M is equal to 5 times 0. 0. So the value of moment at point A is equal to 0. What about point B? How much is the value of x at point B? What is the range of x? What is the range of x? 0 to 5. 5 is point B. So x is equal to 5 at point B. Now if I write down the equation for point B, it will be 5 into 5. That is equal to 25 kilonewton meter. So I have got the equation or the value of moment for point A as well as value of moment for point B. Everybody is clear about this? Okay. 72, please go ahead.
सर यहाँ पर एक फोर्स, ये जो शेयर फोर्स है, ये सारी मूवमेंट क्यों नहीं प्रोड्यूस कर रही?
Because we have written equation of moment at the section location, at this location, and V is actually passing through this location.
Okay sir, समझ आ गया, ठीक.
All right. Next 86.
Yes sir. सर ये जो हम लोगों ने दोनों मूवमेंट्स ली हैं, अब जो पॉइंट ए की थी वो तो हमने मतलब अलोंग उसके लिए ना जहाँ पे शेयर फोर्स एक्ट कर रही थी, और सर जो हमने एम लिया वो हमने ए के अलोंग लिया.
M is by itself a movement. When we have a force, from force we want to calculate movement, then we need a lever arm. Okay, because movement is force into lever arm. When we have a movement, then we are not concerned about any lever arm, right? Although this movement is about this point, but movement is movement. That's why I did not write down, like in the expression, I did not write down any lever arm with M, because M is already a movement. Okay, so there is no lever arm required. But again, the total equation is about this location, about the section. Is that clear?
सर ये M किसके अलोंग होगा, मतलब इसका लेवर आर्म, क्योंकि किसी ना किसी के अलोंग तो होगा ना.
No, M does not have any lever arm. M is a movement by itself. Force needs a movement arm to generate movement. Okay, what is movement? Movement is force into lever arm. So if you have a force, that force should have a lever arm in order to generate movement about that point. But movement is a movement by itself. You do not need any lever arm to convert movement into movement. Movement is already a movement, okay? And it is at the location at this section. We do not need any lever arm for this case.
Yes, ठीक है. Thank you so much.
Okay. Force is force, and in order to generate movement, force needs a lever arm. But movement is not a force. It is already movement. It is a rotational effect of force. So we do not need to multiply this movement with any other thing to convert it into movement. It's already movement. Okay.
Yes, sir. Thank you so much.
All right, 71.
सर ये 5x के बारे में थोड़ा सा गाइड कर दें.
5x. We are calculating movement about this section. Okay. 5 is this force. How much is the perpendicular distance between this force and this location of the section? We have called that x. So what will be the moment of this force about the section? It will be 5x. We are writing down, we are taking sum of movement about the section equal to 0, and this movement is in clockwise direction. So 5x is this movement, and what other movement is there? M is there, and M is in counterclockwise direction. So minus M, and that is equal to 0. And I have rearranged it here, so M is equal to 5x. Is it clear now?
Yes, sir. एक और क्वेश्चन है सर.
Yes.
ये जो V है और M है, क्या ये हमारे लिए लाजमी होता है? ये रूल है कि हमने इनको इधर ही शो करवाना है?
Yes.
ये जो
the location will be this. These are the internal forces at this section. So wherever you are cutting the section, you will show these internal forces. These internal forces are not visible, physical quantities, but these forces are there. So we will always show these forces at the section. These are internal resisting forces that are creating the overall equilibrium. So we will always show these forces here. The flexibility that we have is that we can show this V in the downward direction or in the upward direction. This movement can be shown either clockwise or counterclockwise, but we, for the sake of convenience, have said that we will always show this V in downward direction, and I will always show this M in the counterclockwise direction. This is just for our convenience to get used to of these things. The directions are otherwise flexible, but the location is fixed.
और सर ये जो x है, ये x आपने A से शुरू किया, आपने ऊपर बता दिया था कि ये पॉइंट A और पॉइंट B से जा रहा है, पॉइंट B तक जा रहा है A से. तो क्या हम इसे जिधर से कट किया सेक्शन, उधर से x की डायरेक्शन शो करवा सकते हैं? ये भी रूल है कि हमने एंड पॉइंट वो लेना है जिधर से कट किया. ये जो x का डिस्टेंस है,
x जो है, x is the location of section, and we will always mark it from the left side, left support. We will always do that. Okay, it can never be marked from the section. We will not do that. Okay, because we want to take sum of moment about the section. So for that, the end point of x should be the location of section.
Okay, sir.
Okay. Any other question? Okay, I don't see any other hand raised. So I know that we are solving the very first problem of your life regarding shear force diagram and bending moment diagram. So you guys have a lot of questions and queries and confusions about this thing, but we will be solving a lot of problems. So with the passage of time, these things will get more and more clear. So don't worry about that. And we can discuss these things as many times as needed. So this was first section, first portion AB. Now we have got the shear force and bending moment for this portion. Now let's move to the next portion, portion BC. Let me draw the free body diagram for portion BC. What will be the free body diagram for this portion? Support A. We have this load of 10 kilonewton here, and this is our section, 5 kilonewton. This is X. As I said earlier, we will always be marking X from the left support, and X will be up to the location of the section. Next, what I need to do, I need to mark the internal forces. These internal forces are internal resisting forces and are always there. So whenever you cut a section, you must always show these forces. And according to our convention, V in downward direction and M in counterclockwise direction. So this is a free body diagram for portion BC. Okay, now let me write down the equation for shear. For equation of shear, I will write down sigma Fy equal to 0. And my convention will be upward positive. Okay. How many forces are present on the left side of the section? This 5 kilonewton force acting in the upward direction. So plus 5. What else? This 10 kilonewton force acting in the downward direction. So minus 10. What else? This V is acting in the downward direction. So minus V, and this is equal to 0. If I solve and rearrange it, I get V is equal to how much? Minus 5 kilonewton. So this time we got a value of shear force that's negative, minus 5 kilonewton. But do not worry about that. I'll let you know how to deal with this negative. What does this negative mean? Okay, just leave it as it is. When we will draw shear force diagram, we will take care of this negative sign. Okay. Is there any question? Okay. There's no hand raised. Fine. This was the equation for shear force. Next is the equation for bending moment. Again, we will write down sigma mx equal to 0, and our convention is clockwise movement as positive. This is the convention that we will use. How many forces are creating movement, generating movement about the section? Let's start from here. 5 kilonewton force. What will be the direction of movement of this 5 kilonewton force about the section? This is the section and this is the force. It will generate movement in which direction?
Clockwise.
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 That's right. Whenever we need to check that what is the tendency of any force about certain point to generate the movement, either clockwise or counterclockwise, we just consider that force and we just remove all other supports and all other external forces. We assume the location of the section. Okay, the section is here and here is the force, and then we see that what is the tendency of this force. So tendency of this force is to generate movement in clockwise direction. 5 is the magnitude of force, and how much is the lever arm? How much is the lever arm?
Sir, X.
X. That's very right. And as it is clockwise, so we are taking it as positive. Then what next? 10 kilonewton force. How much or what is the tendency of this 10 kilonewton force? Clockwise movement or counterclockwise movement? It will generate clockwise movement. Okay. Sorry, counterclockwise movement. It will generate clockwise movement. Counterclockwise, sorry. And how much will be the lever arm? This is X and this distance is 5 meters. So how much is the lever arm of this 10 kilonewton force if we are calculating movement about this location? Is it 5? Anyone? Any other idea? We are calculating movement here. Sorry?
X minus 5.
X minus 5.
X minus 5. Yes, that is correct. This distance is X minus 5. X is the total distance from this location up to the section, and this distance is 5, and we are interested in this distance. So this is X minus 5. The direction of rotation is counterclockwise. So minus 10 is the magnitude of load. Lever arm is X minus 5, and that's it. So this is the expression of movement because of this 10 kilonewton load about this section. Is there any other movement? M is the next movement. Direction of M is counterclockwise, so it should be negative, minus 5, and that is equal to 0. We have considered all the movements about the section X. Sorry, what did I write? I write M. I wrote 5, but this is not 5, this is M. Okay. So this is m. Now we need to calculate this m. Now please rearrange this equation and tell me what is m. 5x minus 10x minus 50. So m is equal to minus 5x. This 50 is positive. Okay, so let me write it down first. 50 minus 5x. This is the expression for m. Okay. This is the expression for m. Now, in this expression of m, okay, is there any question? All right. In this expression of m, we have variable x, which means that the value of m is changing in this segment. It's not constant. So what is the segment under consideration? BC. So I'll have to calculate the value of m at point B. X is equal to 5 meter at point B. This implies m is equal to 50 minus 5 times 5. How much is this? Moment at point B. 25 kilonewton meter. What about point C? How much is x at point C?
5.
Wait a minute. Wait a minute. At the top here, I forgot to mention the section name. It is BC, and x will vary from 5 to 10 meters. Okay. The segment is BC, and x will vary from 5 to 10 meters. So the value of m at value of x at point C is how much? 10 meters. So m is equal to 50 minus 5 into 10. And how much is that?
0.
It is 0. Now let's look at these answers critically, whether these answers make sense or not. At point B, how much was the value of movement that we got from section AB? Here it is. Value of movement at point B from section AB was 25 kilonewton meter. How much is the value of movement at point B from section BC? 25 kilonewton meter. These two values should be equal to each other unless there is a point movement at this point B. At this point, we are considering simple cases. So these two values should be equal. In some cases, these two values will not be equal. We will discuss that later on. As a beginner, the simple problems that we will be considering, the value of movement will always be equal from one segment to the other segment at the same point. Value of movement at point B, 25 kilonewton meter here, and the value of movement at point B, 25 kilonewton meter here. So it makes total sense. Value of C, a value of movement as C is 0. Now let's look at our beam. Here is the beam. What do we have at point C? What type of support at point C?
Roller support.
We have a roller support. Can a roller support generate any movement? Resisting movement?
No.
It cannot generate any resisting movement. So the movement at a roller support, at an external roller support and an external hinge support will always be equal to 0. Unless there is an external movement or applied movement. And again, as a beginner, we are not looking at that case. So the movement at roller support, have we applied any movement at this externally applied movement? No, we have not. So what should be the value of movement here? It should be 0. And we are getting 0 here at MC. So our answers are logical. All right, we are getting 0 movement at support C, and it's a roller support, so having 0 movement is totally fine. Okay, 71, please go ahead.
सर ये जो आपने सेकंड डिस्टेंस लिया था, आपने कहा था कि सेक्शन बी सी में ये 5 से 10 तक वेरी करेगा, तो आपने उस वैल्यू को 10 ले लिया, तो हमने सेक्शन तो लाजमी नहीं 10 पे कट किया, 10 पे तो वो रोलर सपोर्ट पड़ी हुई है, ये तो फिर हमारी assumption ना हो गई.
That is true. We are considering the section from point B to C, and the section C terminates like right before point C. This distance is infinitely small, extremely small distance. It is just ending right before C. So it's like 4.99999 and like infinite number of nines. Okay, that's why we did not consider the value, the magnitude of RC while calculating the while writing down the equation for VC and MC. Okay.
और सर एक और बात है, जब आप इस सेक्शन को कट कर रहे हैं, सेक्शन बी और सी के दरमियान लाइन लगा रहे हैं, तो आप इसको बोल रहे हैं सेक्शन बी सी, हालांकि हम पहले पॉइंट ए को भी कंसीडर करके आ रहे हैं, तो इसको क्या हम सेक्शन ए बी सी नहीं बोल सकते फिर, क्योंकि पॉइंट ए भी तो कंसीडर कर रहे हैं ना.
Just go back to the basic definition of shear force and bending moment. I said that when we want to calculate shear force or bending moment, we take the algebraic sum of all the shear forces, all the transverse forces present on either side of the section, either on the right side or on the left side. So if I'm considering this section here, I need to consider all the forces present on the left side or on the right side. This time we are approaching the problem on the left side, so we will have to consider all these forces which are present on the left side. And as the situation is changing, like if I look at the condition of applied loads, it is changing from AB to BC. That's why this equation of shear force and bending moment that I have written here, this is just valid for section BC. It is not valid for section AB. So we will not call that as ABC. This equation is valid just for BC. For segment AB, there is another equation that we wrote previously. But this equation is just valid for BC.
सर अगर ये सेक्शन बी, सर एक और सवाल है कि अगर ये सिर्फ सेक्शन बीसी के लिए वैलिड है, तो आपने मूवमेंट अबाउट ए नहीं निकाला, वो तो हमने पहले निकाल लिया हुआ था, मूवमेंट अबाउट ए इज इक्वल टू 0. अगर ये सिर्फ बी सी के लिए ही वैलिड है, तो फिर इधर भी हमें नया मूवमेंट निकालना चाहिए था. आपने कहना सेक्शन ए बी के लिए वैलिड नहीं है.
Yeah, that's why I have not written, I have not calculated the moment at point A using this equation. So whatever I have done here, that is again reinforcing the point that I am making. This equation is not valid for section AB. That is why I did not calculate the value of moment at point A using this equation. I just calculated the value of moment at point B and at point C, because this equation is for portion BC. This is not for portion AB. Okay.
Okay, sir. Thank you.
All right. 84. Please go ahead.
Yes, sir. सर मैंने आपसे पूछना था कि जब अगर इक्वल वैल्यूज का मतलब मैग्नीट्यूड इक्वल्स हैं कि साइन भी इक्वल होने चाहिए?
साइन भी सेम होंगे in this case.
साइन भी सेम. Okay, sir.
ठीक है. Okay, next. Jannat, please go ahead.
सर ये एक दफा x बता दें कि आपने किस रेफरेंस पॉइंट के हिसाब से निकाले हैं. जैसे कि C पॉइंट है, तो हमें पता है कि वहाँ पे मूवमेंट 0 ही होनी चाहिए क्योंकि लेवल पॉइंट से 0 डिस्टेंस है, तो हमने वो कैलकुलेट ही क्यों किया है?
हमने वो कैलकुलेट ही क्यों किया है? Actually, we have a roller support here and there is no overhang part or anything. That is why it is coming out to be 0. In future, we will be solving some problems where it will not be equal to 0. And plus, this is a check as well on our calculation. Sometimes you will see that you will solve this problem and you will not be, like for the exactly same problem, you will not get a 0 here. That is a check on your calculation. That means that there is something wrong. So calculating moment at point C also serves as a check on our calculation. If I had got, let's say 10 here or 20 here, then I would have said that, oh, there is some problem, mistake with my procedure. I need to go back and check my procedure. So this calculation also serves as a check on my equations. Okay.
ठीक है सर, लेकिन ये x जो है वो 5 और 10 कैसे लिए हैं?
5 और 10 कैसे लिया? This equation
A को रेफरेंस लिया हुआ है.
Yes, A को reference दिया. As I said that we will always be, our initial reference will be extreme left end of the member, left end of the beam. So just see here in this diagram, I have marked X here from the extreme left end, point A. So X is always starting from this point, extreme left point. Okay, that's why for point B, X is equal to 5, and for point C, X is equal to 10.
But
and we will always do that.
ये फर्स्ट इसी के पिछले वाले पार्ट में जो V है उसके अलॉन्ग हमने मोमेंट 0 की है क्योंकि वो डिस्टेंस 0 है, तो वो तो हमें फिर A से लेना चाहिए था.
हमने A से ही लिया है. Okay, which equation you are talking about here? Show me on the this.
Sir, 5x minus m is equals to 0. एक तो m तो मोमेंट है ना, और एक V फोर्स की वजह से मोमेंट थी जो उसको हमने वैसे ही 0 कर दिया क्योंकि डिस्टेंस 0 है.
Exactly.
तो A से फिर मतलब इस हिसाब से तो हमें A से लेना चाहिए और वो तो 5 बनेगा. यानी
we are calculating moment about this point. That is why for this force we have a lever arm of x. But on the contrary, what about V? V is exactly passing through this point. So the lever arm of V for this point is equal to 0. This x is lever arm of 5 kilonewton force which is acting here. So this much is the lever arm. What about the lever arm of this force with respect to this point? 0. Does it make sense now?
Sorry to interrupt you, sir. अभी हमारा lecture है 2 मिनट बाद.
Okay, yeah, I have another lecture too. So we could not complete this problem. So let me just stop here. And when we will start in the next lecture, I will give a quick review of this calculation, and then we will start drawing shear force and bending moment diagram. And if you have any questions,
thank you, sir.
We can start at that point. Okay.
Also, download the attendance, sir.
Okay, I will download the attendance, but be on time. Okay.
Okay, sir.
Yes, sir.
All right. So I'll just stop recording, and I'm leaving here at this point because I also have a lecture at 10 a.m. I need to go to that meeting. If you have any more question, we can discuss that in next class. Okay.
Sir, आप lecture upload कर देंगे?
I will upload this lecture. I will upload this lecture. Don't worry.
Please drive में upload कर दीजिएगा.
I will upload this. Don't worry about that. Okay.
Okay, sir.
Thank you.
Okay. Allah Hafiz.
Allah Hafiz.